Hmm. Okay, so right. Okay, so we are starting with the idea of organic chemistry, and basically, organic chemistry is, you can also call this, let me just choose my pen. Yeah, okay. So organic chemistry is something that we also call as carbon chemistry. And why is that? Because in organic chemistry, we take a look at all of the molecules or all of the compounds, which are also called organic compounds. And organic compounds are compounds that you can say compound, or you can say these are the compounds where you'll have a carbon atom, which will be bonded to either a hydrogen or nitrogen, oxygen, or a chlorine molecule. Okay, so this is the idea of organic chemistry. Basically, it's all about compounds, organic compounds, compounds which have a carbon which is bonded to either hydrogen, nitrogen, oxygen, or chlorine, and those compounds, how these compounds react with other compounds or other molecules is the idea of organic chemistry. Okay, and it's a very easy chapter if you try to understand the basic concepts, right? It's going to be pretty much the easiest you'll have ever seen. Okay, now before we start completely with the idea, there are few things that you might need to know. And one of that thing is the valencies, the idea of what are valencies. Now, valencies are basically, you can say that these are the number of bonds elements can make. So, for example, I said that we'll be studying, let's say, four different elements in this organic chemistry series. Number one is carbon. And carbon, if you look at the periodic table, you will know that carbon has 14 electrons. Okay, 14 electrons. And if you have studied the basics of chemistry, you will know the electronic configuration for this comes out as 2, 8, 4, which means in the outermost shell it has 4 electrons and it can gain 4 electrons to complete its outermost shell. Okay, so that means if it can gain 4 electrons, that means it can also make 4 bonds. And that is what you got as the valency. So the valency for carbon is what? So the valency for carbon is 4. Okay, meaning it can make 4 bonds, meaning that whenever you have a carbon atom in an organic compound, or you can say inorganic chemistry, that carbon atom will always make 4 bonds. Okay, so let's say, okay, I'll give you example later in the video. Okay, so this is carbon. Let's take an example for oxygen. Now, oxygen has 16 electrons, which means the electronic configuration is going to be 2, 8, and 6. To complete its outermost shell, it needs how many electrons? It needs 2 electrons, which means it can make 2 bonds. So the valency for oxygen is 2. The carbon is 4, oxygen is 2. Let's take for it hydrogen. Hydrogen only has a single electron, which means to complete its outermost shell, it needs 1 electron. Because in this case, hydrogen is only completing its first shell because it only has 1 electron. So it gains 1 electron and completes its duplet electronic configuration. Okay, so 1 plus 1, that's 2 electrons. It needs 1 electron. It has 1 electron. It needs 1 electron to complete its outermost shell. That means it can only make a single bond. Hence, the valency is also 1. And one more element which we talked about is nitrogen. Now, nitrogen has, from the periodic table, it has 15 electrons. Okay, 15 electrons means electronic configuration of 2, 8, and 5, which means in the outermost shell, it needs around 3 electrons to complete its electronic configuration. 3 electrons means it needs 3 bonds, or it can make 3 bonds. Okay, so this is something that you need to know. The most main element here is carbon, and you need to know that carbon is going to be making 4 bonds. Everywhere in organic chemistry, we'll be using carbons, and this is very important. Okay, so this is the first idea of, or you can say the introduction to organic chemistry. Now let's take a look at something that we call as the homologous series. Now, you might have seen this from, you know, if you have studied some part of it, you might know what homologous series is, or you might not. But let's try to understand the idea behind the homologous series. Okay, so if I were to write the word homologous, right? So homo means same, and logos basically represents something that you can call as a pattern or a sequence or a series. Okay, which really means is that homologous really means same series, same pattern, same sequence. So it's basically, you can say, if I look at the definition, which says a homologous series is a family of compounds that have the same general formula, and we'll get to what the general formula actually is, and similar chemical properties. This also because they contain the same functional group. Okay, so this really means that you're going to be having different families of organic compounds, right? And all of those families will have some certain properties or some certain formulas, general formulas that are going to be common throughout their series. And you'll understand what this really means. So let's say from this definition, let's try to first understand what is the idea of a functional group. Now, in this particular organic chemistry series, you're going to be studying 5 different series. So you'll have alkanes, you will have alkenes, you will have alcohols, you will also have carboxylic acids, and you'll also have esters. Right? Now, you should know that these are 5 different homologous series, right? And each homologous series is different. How is it different? I'll tell you just a second. So let's say if I take this thing a bit down, I can make some space. Yeah. Okay. Now, how is it different? Let's say I talk about alkanes, for example. Now, you need to understand what is the idea of homologous series. Now, alkanes has this structure, which I think I pushed it downwards. I'll take it forward again, right? Now, this here is what this here are all of the elements, or sorry, all of the compounds of alkanes. This is a methane, this is a ethane, this is a propane, and this is a butane. There's a CH4 molecular formula, C2H6, the other molecular formula, C3H8 and C4H10. What you need to understand, if you look at the definition again, the definition says a homologous series is a family of compounds that have the same general formula, similar chemical properties because they contain the same functional group. Now, functional group here is something that describes, or you can say something that tells you how the compound is going to be reacting with other molecules. So for example, let's say we talk about the homologous series of alkanes. Now the journal, or you can say the functional group of alkane tells you how alkene is going to be reacting with other molecules. Okay, and this functional group basically gives whole of the idea of chemical properties. Okay, because if you notice, chemical reactions is basically chemical properties. The way a substance reacts is also something that we call as chemical properties. Now, if I were to if I were to show you a molecule of alkane, this is how CH4 looks like. Molecule of this is a molecule of alkane, right? CH4. Now, what we're
हेलो
trying to understand,
हेलो हेलो
yes, 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 आवाज आ रही है मुझे.
हेलो सर एक काम है
हम्म.
सर इसमें एल्केलाइन क्यों होगा
एल्केलाइन कहाँ है? एल्कीन्स है.
जी तो ये एल्कीन क्यों है
ऑर्गेनिक केमिस्ट्री है ना. ऑर्गेनिक केमिस्ट्री का जो ओ लेवल का सिलेबस है उसमें एल्केन्स एल्कीन्स इंक्लूडेड है.
तो इसमें तो फॉस्फोरस और मेठोजीन भी होते हैं
सॉरी.
उसमें तो फॉस्फोरस और मेठोजीन भी होते हैं
फॉस्फोरस नाइट्रोजन, एक मिनट लेट मी लुक एट द सिलेबस। मैंने जो लास्ट सिलेबस चेक किया था उसमें तो इंक्लूडेड नहीं है।
नहीं, अभी अपडेट हुआ है रिसेंटली।
एक सेकेंड। 26 को फॉलो कर रहे हैं ना? राइट।
जी जी। जी यस।
ऑर्गेनिक केमिस्ट्री 11। एल्कीन्स 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 अल्कोहल कार्बोक्सिलिक एसिड्स। नहीं है इसके अंदर तो चार ही है। एल्केन्स है, एल्कीन्स है, अल्कोहल्स और
ओ,
कार्बोक्सिलिक एसिड्स है।
ठीक है सर, यही पूछना है, थैंक यू।
ठीक है। अच्छा, what we were trying to understand was कि functional group, how do we और we were trying to identify the functional group। अगर हम alkanes की बात करते हैं तो alkanes के अंदर जो functional group होता है, basically we say कि alkanes के अंदर कोई functional group नहीं होता। why? Because alkanes जितने भी हैं, we call alkanes as saturated hydrocarbons। ठीक है, saturated hydrocarbons। हाइड्रोकार्बन्स का मतलब ये होता है कि all molecules। हम्म यार प्लीज एनोटेट नहीं करो ऊपर से। How can I remove this? Wait. Okay, सही है। थैंक यू। सही है। हाइड्रोकार्बन्स क्या होते हैं? हाइड्रोकार्बन्स बेसिकली और ऑल ऑफ योर कंपाउंड जो कि किससे बनते हैं? वो बनते हैं हाइड्रोजन एंड कार्बन से। हसान, यू आर एनोटेटिंग ऑन द स्क्रीन बडी। ऑल ऑफ द एलिमेंट्स और ऑल ऑफ द कंपाउंड्स आर मेड अप ऑफ हाइड्रोजन एंड कार्बन। उनको हम क्या कहते हैं? उनको हम कहते हैं हाइड्रोकार्बन्स। नाउ फॉर एल्केन्स, क्योंकि ये प्योरली हाइड्रोकार्बन्स है एंड सैचुरेटेड मींस सिंगल बॉन्ड hydrocarbons. Okay, so what do we say? We say that methane, or you can say the alkene molecules, they do not have a functional group. उनकी जो only identity है वो है that they'll have single bonds. Okay, you can see it from here. CH4 methane के अंदर भी क्या है? You only have single bonds. You have carbon and hydrogen, and you only have single bonds. If you look at ethane, उसके अंदर भी you have carbon and carbon bonded to each other, but with a single bond. और हाइड्रोजन भी जितने हैं, those are also with what? Single bonds. Same goes for propane and same goes for butane, right? And because we say that alkenes do not have a functional group, so you know what I said previously as well, कि फंक्शनल ग्रुप डिसाइड करता है कि आपके जो एलिमेंट्स हैं वो कैसे रिएक्ट करेंगे, लाइक उनकी केमिकल प्रॉपर्टीज क्या होंगी। लेकिन बिकॉज दे डोंट हैव अ फंक्शनल ग्रुप, बिकॉज एल्कीन्स डोंट हैव अ फंक्शनल ग्रुप, इसलिए वी कॉल देम जनरली unreactive। Okay, they are generally unreactive। Say, so that's the idea. Now, for a homologous series, there are a few points that we need to understand। क्या क्या पॉइंट्स होते हैं? एक तो ये कि we just looked at the functional group। तो for any given homologous series, let's say कि मैं alkenes की बात कर रहा हूँ, ठीक है, लेट्स आई एम टॉकिंग अबाउट द एल्केन्स। एल्केन्स के अंदर जो है जितने भी एल्केन मॉलिक्यूल्स होंगे, दे विल ऑल हैव द सेम फंक्शनल ग्रुप। आई एम राइटिंग इट एज Fg, सेम फंक्शनल ग्रुप। और वो हमें यहाँ नजर भी आ रहा है, सारे सिंगल बॉन्ड्स है। व्हाट डू वी से दैट ईदर दे डोंट हैव अ फंक्शनल ग्रुप, या फिर हम कहते हैं कि अगर हमने कोई फंक्शनल ग्रुप नेम करना भी है तो वी विल जस्ट से दैट इट हैज अ सिंगल बॉन्ड। तो इसके अंदर बिकॉज एल्केन्स ऑल ऑफ देम हैज सिंगल बॉन्ड्स, वी कॉल देम एज single bond hydrocarbons। or the first point of the series is that, or the first point of the general characteristics is that कि एक होमोलोगस सीरीज के अंदर, एक इंडिविजुअल होमोलोगस सीरीज के अंदर, लेट्स से दैट आई एम टॉकिंग अबाउट एल्केन्स, तो आपके फंक्शनल ग्रुप क्या होंगे? सेम होंगे। ठीक है ना? नेक्स्ट थिंग, द नेक्स्ट आइडिया इज all of them are going to have similar chemical properties, not same, similar chemical properties। अच्छा, why is that? Because we just saw दैट जो आपकी केमिकल प्रॉपर्टीज होती हैं वो किससे निकलती हैं? फंक्शनल ग्रुप से निकलती हैं। अगर एक इंडिविजुअल सीरीज के अंदर फंक्शनल ग्रुप इज द सेम, दैट मीन्स कि उस सीरीज के अंदर जो केमिकल प्रॉपर्टीज हैं दैट इज ऑल्सो गोइंग टू रिमेन द सेम, ठीक है, एंड नॉट एग्जैक्टली द सेम, सिमिलर। सेम और सिमिलर, व्हाट इज द एग्जैक्ट डिफरेंस? यू कैन से कि बिकॉज क्या होता है कि हर, if I go down the series from here, you see, ये CH4 है, ये C2H6 है, ये C3H8 है, ये C4H8 H10 है. So the moment I'm going down the series, what is happening? The molecule is getting bigger and bigger. तो जितना molecule बड़ा होता जाएगा, तो जो केमिकल प्रॉपर्टीज हैं वो थोड़ी बहुत चेंज होती जाएंगी, इसलिए हम सिमिलर का वर्ड यूज कर सकते हैं, वी डोंट यूज द वर्ड सेम फॉर दैट, ओके। सो सेम फंक्शनल ग्रुप, फर्स्ट पॉइंट, similar chemical properties is the second point. Okay, these are two ideas. The third idea is कि जब भी we are talking about all of the compounds in an organic, or you can say homologous series, so every next element is going to differ by a CH2 unit. Acha, what does that mean? If I look at the, if I look at here, let me just erase that as well. अगर मैं यहाँ देखूं, you see, the first element here is one and indeed. Okay, the first element here is CH4. CH4 है, you have one carbon and you have four hydrogens. सही है। If I look at the next one, next molecule, so इसमें you have two carbon and six hydrogen. और इसका molecular formula क्या है? C2H6. अगर मैं तीसरे वाले को देखता हूँ तो उसमें C3H8, which means you have three carbon and eight hydrogen, not four. And you've got eight hydrogens. If I look at the fourth one, that is C4H10, इसके अंदर आपके पास चार कार्बन है and you have got 10 hydrogens. So you see, अगर मैं कंपेयर करूं तो यहाँ पे एक कार्बन चार हाइड्रोजन, नीचे अगर मैं जाऊं तो दो कार्बन और छह हाइड्रोजन, विच मीन्स के यहाँ से यहाँ आने में आई गॉट एन एडिशनल CH2 यूनिट, यानी मेरा एक CH2 और ऐड हो गया, एक कार्बन और दो हाइड्रोजन और ऐड हो गया। इफ आई गो डाउन फर्दर तो मेरा एक और CH2 ऐड हो गया, एंड इफ आई गो डाउन फर्दर अगेन तो मेरा एक और CH2 यूनिट जो है वो ऐड हो गया। तो जब भी मैं एक कार्बन बढ़ाऊंगा, यानी मैं सीरीज में जो है नीचे जाऊंगा, मीथेन, इथेन, एंड आई गो डाउन द सीरीज फर्दर, तो हर बार क्या होता जाएगा, मेरा जो एक कार्बन मेरे बढ़ाने पे दो हाइड्रोजन्स और ऐड हो जाएंगे, एंड दिस इज कॉमन फॉर एवरी सीरीज, राइट? ईच मेंबर डिफर्स बाय एडिशनल CH2 unit. सही है। This is the third point. The fourth point is, as we go down the series, there is a gradual change in the physical property. Now, what are physical properties? Physical properties का मतलब ये होता है कि जो boiling points हैं, melting points हैं, viscosity है, viscosity is basically thickness, कि किसी भी liquid की कितनी thickness है, right? That is the idea of viscosity. So when we talk about physical properties, we say that as we go down the series, जितना हमारा मॉलिक्यूल जो है वो बड़ा होता जाएगा, there will be a gradual change in the physical properties. And what is that gradual change? For example, मीथेन का जो मेल्टिंग पॉइंट है या बॉइलिंग पॉइंट है, इथेन का उससे ज़्यादा होगा, प्रोपेन का उससे ज़्यादा होगा, ब्यूटेन का उससे ज़्यादा होगा, फिर आगे पेंटेन का उससे ज़्यादा होगा। तो बॉइलिंग पॉइंट्स और जो विस्कोसिटी है, दे गोइंग टू बी इंक्रीजिंग एज वी गो डाउन द सीरीज। Okay, so this is the idea about, I'll just write this down as well. Gradual change in the physical properties. Gradual change in the physical properties. Now, these 4 points, कौन से? Same functional group, similar chemical properties, an additional CH2 unit, and gradual change in physical properties. These 4 points are going to be remain similar or same for every, you know, homologous series. चाहे वो फिर alkane हो, alkene हो, alcohols or carboxylic acids हो. And I also solve this with alkenes molecules as well. ठीक है, let me solve it with that. Let's say कि मैं alkene की homologous series की बात करता हूँ। I have to prove all of these 4 points, right? पहला पॉइंट मेरा क्या था कि it's going to have a same functional group. Functional group क्या होता है? Something that decides how the molecule is going to be reacting with other molecules, right? So let me take the first point is same functional group. We can also see that कैसे the first element in sorry, the first molecule in the alkene series is ethene, right? ethene होता है C2H4. ओके, एंड इफ आई गो फर्दर, ईथीन के बाद कौन सा मॉलिक्यूल आता है? ईथीन के बाद मॉलिक्यूल आता है प्रोपीन। which is C3H6. मैं थोड़ा सा और आगे जाऊं तो that would be butene. Butene is C4H8. And if I were to draw the structures for all of these molecules, let's say कि मैं इनके structures बनाता हूं. This is C2H4, right? Propene is going to be something like this, double bond here, and 1, 2, 3, 4, 5, 6, and a carbon here. Right, so 1, 2, 3, 4, 5, 6. I've missed one carbon. 1, 2, 3, 4, 5, 6, 7, 8. और एक carbon यहाँ पे भी आएगा सही है 1, 2, 3, and there's going to be one more carbon. Okay, so 6 carbon here. And then C4H8, so 4 carbon molecules, a double bond, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12. हो गया पूरा सही है. And even if you look at this point, so if you remember I talked about valencies कि carbon की valencies बड़ी important है because carbon only make 4 bonds. So if I look at this point, so you will realize that each carbon here has made 4 bonds. So if I count 1, 2, 3, 4, तो ये इस कार्बन के 4 बॉन्ड्स हो गए. इफ आई लुक एट फॉर दिस कार्बन तो 1, 2, 3, 4, तो ये इस कार्बन के 4 बॉन्ड्स हो गए. इफ आई लुक एट फॉर दिस कार्बन सो दिस इज 1, 2, 3, 4, इस कार्बन के 4, एंड फॉर दिस कार्बन इट्स 1, 2, 3 एंड 4. और हाइड्रोजन क्योंकि एक ही बनाता है तो दिस यू गोना काउंट इज दिस एज 1, 1, 1, 1, right? These are all of the alkene molecules. Acha, the first idea is same functional group. Now, same functional group for alkenes is what? Is a double bond. Okay, whenever you see a double bond, it's going to be what an alkene molecule until उसके साथ कोई OH attached हो तो फिर वो कार्बोक्सिलिक एसिड की तरफ से हम चले जाते हैं. लेकिन और वो भी जो डबल बॉन्ड होता है वो ऑक्सीजन के साथ होता है, कार्बन के साथ नहीं होता. सो whenever you see a carbon double bond, you're going to realize that this is what an functional group of alkene. अच्छा, अब इसके अंदर भी you have got this functional group, इसके अंदर भी है और इसके अंदर भी है. So that gives you the idea कि एक particular होमोलोगस सीरीज के अंदर अभी हम एल्कीन्स की बात कर रहे हैं तो उस एल्कीन की सीरीज के अंदर जितने भी हम एल्कीन के मॉलिक्यूल्स को लिखेंगे ऑल ऑफ देम विल गोइंग टू हैव द सेम functional group, and that functional group is what? A double bonded carbon. That is your first point. Second point हमारे पास क्या था? Second point हमारे पास क्या था? They are all going to have similar chemical properties, right? Now इसका मतलब क्या है कि all of these molecules is ethene, propene, butene, and further down, they are going to react in a similar manner. अब वो रिएक्शन जो है होगा, ये सिमिलर का मतलब क्या है कि थोड़ा सा चेंज है. फॉर एग्जाम्पल दैट मीन्स कि माइट बी पॉसिबल कि इथीन थोड़ा ज्यादा रिएक्टिव हो, प्रोपीन उससे थोड़ा सा और ज्यादा रिएक्टिव हो, ब्यूटीन उससे माइट बी पॉसिबल माइट बी मोर रिएक्टिव. तो इट्स जस्ट जो रिएक्ट जो रिएक्शन है उसका उसमें कितना डिफरेंस है, दैट इज व्हाई वी यूज द टर्म सिमिलर केमिकल प्रॉपर्टीज. थर्ड पॉइंट थर्ड पॉइंट इज एन एडिशनल CH2 यूनिट. मतलब आप जितना भी नीचे जाते जाओगे सीरीज में तो यू विल ऑलवेज ऐड एन एडिशनल CH2 यूनिट. इन दिस केस यहाँ पे देखो C2H4 था, यहाँ पे जब प्रोपीन पे है C3H6 हो गया, ब्यूटीन पे है तो C4H8 हो गया. तो C2H4 यहाँ 2 कार्बन, 4 हाइड्रोजन्स. प्रोपीन पे यू हैव गॉट 3 कार्बन, 6 हाइड्रोजन्स. And butene पे you've got 4 carbon and 8 hydrogens. So every time you go down, आपके पास क्या बढ़ रहा है? आपके पास एक CH2 unit is getting increased. And this is common for every homologous series, be it alkene, alkenes, carboxylic acid, alcohol. ये सबके लिए common रहेगा, right? And the last point is the idea of that as you go down the series, and जैसे जैसे आप ethene से propene और butene पे जाते हो, तो there is going to be a gradual change in the physical properties, meaning the viscosity, the boiling points of propene is going to be higher than ethene. The boiling point of butene is going to be higher than the boiling point of propene. So this is the idea about the homologous series of every organic family. The same goes for alcohols and the same goes for what do you call it? Carboxylic acids. Okay, यहाँ पे you have got this chart which shows you the functional groups for every. Okay, so this is for alkenes. Might be possible. ठीक है. ये alkanes के लिए है. Yeah, I can write, what I can do, I can write the functional groups for every, you know, homologous series. So for alkanes के लिए हमारे पास कोई series नहीं होती, कोई functional group नहीं होता. If you want to write a functional group, you can just say that it has a single bond. Okay, this is for alkenes. For alkenes, for alkenes, that is a carbon-carbon double bond. That is your functional group. Okay, for alcohols में आपको कैसे नजर आएगा? Alcohols में you will see an OH molecule, right? And for carboxylic acids, for carboxylic acids, what you will see? You will see a C double O H in either your molecular formula or either in your compound. अब जाहिर सी बात है, when we go into later chapters or later videos, so we'll get into much more detail for this. Now, there's one more small thing that I want to do in this conceptual thing, and that is how do you name these organic compounds, right? How do you name these organic compounds? Which is pretty simple. All of the organic compounds are basically divided into two parts. One is something that we call as the prefix part, and the other is something that we call as the suffix part. Prefix जो होता है वो आपका first part होता है name का. Suffix जो होता है वो आपका second part होता है name का. And prefix and suffix both tell you some part of the name. Okay. सही है. They tell you some part of the name. अच्छा, prefix, what does prefix does? What does prefix does? अच्छा, prefix आपको बताता है कि किसी भी कार्बन के अंदर, सॉरी, किसी भी कंपाउंड के अंदर हाउ मेनी कार्बन्स आर गोइंग टू बी देयर. ठीक है. फॉर एग्जांपल, इफ आई वर टू राइट अ टेबल हियर व्हिच इज 1 2 3 4 एंड 5. सही है. प्रीफिक्स यू हैव गॉट फॉर एवरी नंबरिंग, आपके पास कोई नेम होता है. सो फॉर एग्जांपल, इफ यू हैव गॉट वन कार्बन इन द कंपाउंड, वो क्या होगा? मेथ. इफ यू गॉट टू कार्बन इन अ कंपाउंड, वो हो जाएगा एथ. इफ यू गॉट थ्री कार्बन इन अ कंपाउंड, वो हो जाएगा prop. इफ यू गॉट फोर कार्बन इन अ सिंगल कंपाउंड, वो हो जाएगा ब्यूट. और अगर वो फाइव कार्बन हो तो दैट विल बी पेंट. ठीक है. एंड दैट रियली मीन्स कि एक कार्बन का मॉलिक्यूल, दो कार्बन, देन थ्री कार्बन चेन, एंड देन फोर कार्बन चेन, right? And then here five carbon chain. And suffix part is something that tells you the homologous series. Homologous series जो आपको बताती है वो क्या होती है? सफिक्स पार्ट होता है. इफ द सफिक्स इज लाइक इन, तो उसका मतलब होता है कि दिस बिलोंग्स टू एल्कीन. अगर सफिक्स में साउंड आ रही है इन, दैट मीन्स इट बिलोंग्स टू एल्कीन. अगर उसमें आ रहा है ओ एल, दैट मीन्स इट इज अल्कोहल. और अगर उसमें आ रहा है ओ आई सी एसिड, then that of course means that this is going to be what? Carboxylic acid. Okay. So, for example, if I were to write a few names, so let's say methane. A methane tells you meth, tells you that this is going to be a one carbon molecule, and ene tells you that it belongs to the family of alkene compounds, right? If, for example, there was something we call as propanol. A propanol, there are two parts, prop and all. Now, this tells you that this belongs to the homologous series of alcohol, and prop tells you the number of carbon atoms. और कितने होते हैं prop? Prop is actually three carbon. Now you know that this is going to be a three carbon alcohol molecule, and you can also draw it by the way. So if I were to draw this, you already know कि तीन carbon का molecule होगा, and every carbon has the tendency to make four bonds. So one, two, three, and this one is four. And you can draw this OH, यानी alcohol का जो H है, you can put it anywhere you want. So this is one, two, three, four, and you can draw the OH part here. Okay, so this is the idea of homologous series and the idea of naming organic compounds. If you guys have any questions, you can ask me. Take it because this is about to end in around 6 minutes. I'm waiting if you guys have any questions.
Hamza, I just wanted to ask, what is the difference between a displayed formula and a structural formula and a molecular formula?
Okay, yeah. Sorry, I muted myself. Right. So displayed formula, structural formula, and
And a molecular formula.
molecular formula, right? अच्छा, so there are two names in this जो कि मैं भी confused हो गया हूँ. I just have to see. Two of these things mean this exactly the same thing. Molecular formula, and I'll also write this. You've got displayed formula, you've got molecular formula, and you've got the structural formula. Now, displayed formula and molecular formula to an extent will always feel the same, right? Let's say कि मैं
Yeah.
बात करता हूँ मीथेन की, right? Methane is CH4. So CH4 is going to be the molecular formula. Molecular formula का मतलब ये होता है कि anything that tells you कि एक compound के अंदर how many carbon atoms are present or how many hydrogen atoms are present. यानी it just tells you कि let's say अगर यहाँ पे CH4OH भी होता तो it's gonna tell you कि कितने कार्बन के एटम्स है, कितने हाइड्रोजन के एटम्स है, कितने ऑक्सीजन के एटम्स है. That is what molecular formula is, right? If I
Yes.
were to write it for ethane, the ethane would be C2H6. That is your molecular formula. Displayed formula is also somewhat the same. Or displayed formula is also something that you can write as like this because interchangeably use होता है structure और displayed. Structure कैसा होता है? CH4 where you have to draw the structure. See? H4. This is a structured form.
Right.
अगर कोई और compound होता, let's say if it was ethane, you would draw the structure for ethane if they had asked you for the structure formula. Displayed formula, molecular formula, they'll use interchangeably. मतलब वो they'll say कि draw the displayed formula. If they say draw the displayed formula, then of course you might even want to draw the structural formula. क्योंकि वो कहना draw. It's more about how they use the wordings. सही है. If they say कि write down the molecular formula or write down the displayed formula, you write it in just this way.
Right. All right.
Okay. Do you guys want to ask anything else?
All right, so I guess that's all for our class, Hamza.
Mm-hmm. So yeah. Okay, सीन है. So right, मैं जरा recording pause कर देता हूँ.
Hmm.